Hi friends, I am Dr. Arjun Chauhan. I am going to talk on the stereochemistry. Stereochemistry is the branch of chemistry which deals with the three-dimensional arrangement of the atoms and molecules and their effect on the chemical reaction. It is called the stereochemistry. One basic important term in the stereochemistry is the isomers. Now what is meant by isomers? Isomers are the two compounds which have the same molecular formula but different structure. They are called the isomers. And there are different types of isomers in the organic compound. Now if the two compounds don't have the same molecular formula, then they are not the isomers. If they have the same molecular formula but they have the different structure, then they are the isomers. And these isomeric compounds are mainly divided into two types. One is the stereoisomers, another one is constitutional isomers. And these two types are mainly based on the connectivity of the atoms in the molecule. If they have the same connectivity, then they are called the stereoisomers. And if they have the different connectivity of the atoms, then they are called the constitutional isomers or structural isomers. See, these are the two isomeric compounds, that is isopropyl alcohol and ethyl methyl ether. They have the same molecular formula, but their structure is different due to the connectivity of the atoms. So that's why they are called the constitutional or structural isomers. In case of stereoisomers, they will have the same molecular formula, same structure, but three-dimensional arrangement of the atoms will be different. And these stereoisomers are again subdivided into two types. One is the conformational isomers, another one is configurational isomers. Now, what is the difference in conformational and configurational isomers? These conformational isomers undergo the interconversion due to carbon-carbon single bond rotation. See this staggered conformation of N-butane and eclipse conformation of N-butane. They will undergo the interconversion due to C2C3 single bond. But this will not be the case in the configurational isomers. So these configurational isomers are again subdivided into two types. One is the geometrical, another one is the optical. So the main difference between these two isomers is the presence of tetrahedral center or chiral center. What is meant by tetrahedral center or chiral center? Is the center which is attached to four different groups. If that kind of center is absent, then that is the geometrical isomer. If it is present, then it is the optical isomer. See, these geometrical isomers are also called as cis-trans isomer. And these are the two isomers of 2-butene. One is the trans, another one is cis. In trans 2-butene, two methyl groups are on the opposite side of this double bond. In cis 2-butene, the two methyl groups are on the same side of this double bond. And in optical isomers are again subdivided into two types, enantiomers and diastereomers. Now, what is the difference in enantiomers and diastereomers? Is the enantiomers are the isomers which are non-superimposable mirror images. Means these two isomers are the mirror images of each other but non-superimposable. Means like our hands. These two hands looks like a mirror image of each other, but these two hands are not superimposable. So these are called the enantiomers. And the diastereomers are the isomers which are not mirror images. See, these two compounds, they have the same molecular formula, but they are not the mirror images. So they are called the diastereomers. So these are the different types of isomers in the organic compound.